Hello,
Hi.
hello,
Yes, ma'am.
hello.
Check, check.
Yes, ma'am, you are audible.
Hello.
Yes, ma'am.
Okay.
We can
Yes, ma'am.
hear.
Good morning, everybody.
Good morning, ma'am.
Good morning.
Last class, I think in your section also we have done pre-stress. Pre-stress, I have discussed with you all the pre-stress, the methods of tensioning, types of how we can provide pre-stress. Is there any doubt in the previous class from the previous class? Pre-tensioning, post-tensioning, no doubts. Okay, then if I share my screen now. Mm, yes, I have logged the meeting. Okay, now participants we have 40. Is there more students to come?
Yes, I guess.
Hello. Is there any more students to come?
Not sure.
Okay, I don't know. I have logged the meeting now. Now we'll start with the class. If I share my screen here now, are you able to see the screen?
Yes, ma'am.
Yeah. Mm, So I think last class we have done with this forms of pre-stressing steel. Last class about the pre-stress, the tension, pre-tensioning, post-tensioning, uh, tendons. Uh, last this one, last thing we have discussed was forms of pre-stressing steel. What are actually tendons which we are going to use in our pre-stressing concrete, right? This thing we have discussed, now in your section, forms of pre-stressing steel. Hmm?
Yes, ma'am. Yes, ma'am.
Okay. Then today Now, if we go to the advantages of pre-stressing, today we'll see what are the advantages of pre-stressing. So here it is mentioned sections remain uncracked under service loads. Sections remain uncracked under service loads. As I told you in your last class, that RCC structures, since your concrete is weak in tension, therefore what happens at the bottom of the beam, you will see cracks during their service loads after the concrete has taken the all the stresses which it could take, the tensile stresses, and the furthermore it could not take, that means because concrete we know it is very much weak in tension. So therefore we have seen cracks, but in pre-stressing, since they are very much strong, and that's why we use pre-stressing tendons, and we have uh, performed the pre-stressing process. Why? So that they can have higher strengths and higher strength in terms of tension. Okay, so that they can carry more tension as well as compression by the concrete. Then that's why sections remains uncracked under service loads in most cases, in mostly. Then these pre-stress concrete members are used in high span to depth ratios, as already mentioned to you that we use this pre-stressed materials in like bridges, flyovers, etc., where we have the higher span to depth ratios. So in those cases, we can use this kind of pre-stressed materials or pre-stressed beams. Okay, and also these pre-stressings are what is the another advantage is that suitable for precast construction. You can see in the present scenario, if you see, when we construct some bridges, we are constructing some bridges. In some of the cases, like we have seen in the, if you have seen the Bogeyville bridge also, there the precast beam abutments are, what is done, they are already precast and then they are joined together, okay, to form that bridge. That means already they are made, the whatever you want, the suppose for a you are making a larger span beam in some maybe in some of your garage or somewhere in a high shopping area, commercial area. If you want to make, in that case you have a large huge this thing, budget is also large, then if you are making that pre-stressed beam in your, suppose I'm telling you, like parking zone in a this thing shopping area, suppose, then what happens in those cases, those beams you can already construct and then you can bring on the site. Also you can see some of the pre-stressed members are the electricity poles also, you can see that is not constructed sometimes, that is not constructed on the site itself, but they are precast and then they are brought to the site and then it is placed on the area wherever it is required. So pre-stressing is beneficial when you want it to be precasted. Already you make the member or the part of the structure there itself, and then on your, then you bring on your site where you want to place it. Okay, these were the advantages of your pre-stressing. Now if we come to the limitations of pre-stressing, what are the limitations? Pre-stressing needs skills technology, because we are very much familiar with RCC, but we are not familiar with pre-stressing much here in India. Okay, there are, now it is almost it is done in some of the places and wherever it is required. Then like in, okay, precision is, and therefore we'll need obviously skilled technologies, and we um, hence it is not common as reinforced concrete. I think you people will understand if you go through this once. The use of high strength materials is costly. Yeah, because in pre-stressing, the tendons used, those are very much high strength steels, and so they are higher in cost as compared to the steels rods. Okay, and also since we are using in pre-stressing, we use in larger span to depth ratios. So obviously there is, that means when you're using pre-stressing, your concrete is amount of concrete is more, your tendons used is more, and therefore ultimately your cost is higher, because the grade of concrete also which you are using is of higher grade, because we are taking this pre-stressing method. Why? Because of the higher loads and higher depth to span to depth ratio. So obviously the cost goes higher. There is additional cost in auxiliary equipments. Okay, some of the equipments also you will require if you are pre-stressing some members. Then you will need, what you will do, you are going to pull the tendons, and you are going to give tensions. You are going to give tensions. So that means what? For that you will need jacks, hydraulic jacks, and then for anchoring also you will need equipments. So extra, these are some of the extra equipments which you will require when you do the pre-stressing, which are not required in your RCC when you construct some RCC, normal RCCs. Okay, and also in the pre-stressing, there is need for quality control and inspection, because there will be, due to this pre-stressing, there will be some losses also in the stresses. Okay, so quality control and inspection is also done. Now, if I ask you people to give me some of the advantages of pre-stressing over RCC, what you are going to say? Hmm?
Has more durability.
Okay, wait, let me stop sharing screen. Yeah, I came to your can withstand heavy loads, snow vegetation burning. And we do one thing, you people, whoever, how many of you are there, do one thing. I have not made uh, this topic. Okay, so I think you take note down the differences between the pre-stressed concrete and the reinforced concrete. Make a column and write there, the one side, on the left hand side you write the pre-stressing concrete and the reinforcement concrete. We'll discuss some points over the pre-stressing concrete and the difference between the pre-stressing concrete and the reinforced concrete. Fine. Okay. Hello.
Pre-stressing concrete and
Yeah, on the left hand side you make a column where you write pre-stressed concrete. On the right hand side you make a column of reinforced concrete. Okay.
reinforcement.
Yeah, RCC, reinforced concrete. One is your pre-stressed concrete, one is your pre-stressed concrete, one is your reinforced concrete. On the other hand, make a note on that, because what you think about the stresses which are generated on the pre-stressing concrete, about the stresses in the pre-stressing concrete and RCC? Anyone? What is the basic? If you think about RCC and the pre-stressed concrete, what do you think about the stresses there? Anyone can comment, or you can speak also. Anything about the stresses in the pre-stressed concrete and the RCC? Hmm? No. Okay, then you write in the pre-stressing concrete. In pre-stressed concrete, stress is almost constant. Okay, Pallab Talukdar, in pre-stressed area is more. Yeah, area is to more. But what about the stresses? See, in pre-stressed concrete, we already generate the stresses. So what happens? Since we develop the stresses, we know that these stresses are going to be there in the pre-stressed member which we have developed, which we have constructed. Okay, so we know that this is the stress and this is going to be constant. But in RCC, the stress in steel varies with the linear area. Okay, so in your left hand side in pre-stressed concrete, you write there one point that pre-stressing concrete in pre-stressed concrete, stress is almost constant. Okay, understood this point? Because see, in pre-stressing, we already developed these stresses there, compressive stresses. So there are less chances of your stresses to change. But in RCC, what happens? Due to the loading, we don't know about how much load is going to fall in our RCC structure. So when we have an assumption that this much is going to fall, but it may increase. So as the load increases, the stresses inside the RCC reinforced concrete, the stresses also develops, and we don't know about the stresses as much. Whatever load is going to fall on your reinforced concrete, stresses, that much stresses are going to develop. It may be more, it may be less, those all stresses are going to develop. But in pre-stress, you already have tensioned the tendons and you have given the stress, and you are aware that this much stresses may be generated, this much pre-stressing stress has been generated, and this is when the load is going to fall, this is going to counterbalance. Like if from top it is from external load is your 100 kilonewton, and your pre-stressing force which is developed is suppose 90 kilonewton. So that means what? Now the extra stress which is going to develop is 10 kilonewton on the pre-stress concrete. So regarding the stress, it just remains almost constant, we know. But in RCC, it changes with the loading. That how much load is there, that much is your stresses are going to change depending upon the loading. So have you written the first point? In pre-stress concrete, stress is almost constant, and on the reinforced concrete RCC, the stresses in steel is variable with the linear area. Okay, done? Done? Or shall I repeat? Hello?
Repeat, ma'am.
Okay.
Pre-stress stress is
In pre-stress, in the column of pre-stress, you write that the stresses here is almost constant. In pre-stress concrete, stresses are almost constant. Done. In the RCC column, you write, in the reinforced concrete column, you write RCC, the stress in steel is variable with the linear area. The stress in steel is variable with the linear area. Done.
done, ma'am.
Okay. Next, number two, you write that it has in the pre-stress concrete, it has more shear resistance. Done? Hello?
Yes.
Done. Na? So in the RCC, what you'll write, it has less shear resistance. Obviously, the shear resistance will be more, because it has a higher strength, your tendons, yeah, and tension is also more. So equally, the compression and tension is distributed in the your pre-stress concrete. Okay. So the shear resistance is more here in your pre-stressing concrete. Done? Okay. Yes. Okay. Pre-stress next, right? Number. Pre-stress concrete is more grade of concrete is used. Somebody said just now they are more durable. That was Kelsang Pungsuk. So that point you're going to write, which Kelsang had said that pre-stress concrete is more durable as high grade of concrete is used, which are more dense in nature. And RCC is less durable.
And once more, please.
Pre-stress concrete is more durable as high grade of concrete is used which are more dense in nature. Next, in RCC you write RCC is less durable. Next, done. No? In pre Next you write in pre-stress concrete members. In pre-stress concrete members, pre-stress concrete members, in pre-stress concrete members, steel plays active role. Hello? In pre-stress concrete members, steel plays active role. The stresses in steel, the stresses in steel, whether I don't know. Writing?
Ma'am, my link got crashed and I joined again, ma'am.
That's why I unlocked the meeting because some of them are joining till now.
Can you repeat again, ma'am? Pre-stress
In
concrete, stress is
concrete
concrete,
members,
stress is constant, and RCC variable something.
constant. Hmm. variable with the linear one. Otherwise, you take it as an assignment, okay, everybody. Like you write down the differences between the pre-stressed concrete and your RCC, reinforced concrete. Okay.
And this is better.
Yeah, because it is taking time like this. So in you do the assignment, take it as an assignment. Let me write here also. Differences, difference between pre-stressed concrete and okay, take it as assignment. Okay, now if I share another screen here, you people take it as an assignment, and this is section A, right? I'll be or in the next class, so we will discuss about the this thing differences, because you'll take it as an assignment. Then who has written what, I'll just simply you tell me there in the class. Okay, I'll not collect soft copies. You just tell me what are the, ma'am, can we submit in MS Word? You people want to submit in MS Word?
Ma'am.
Hmm? Okay, I'll do one thing. I'll share a link. I'll share a link where you can attach your this assignment. You can write in your any page, or you can, if you want, you can write in your MS Word. If you write in your this thing a page, then you can scan and then give me as an attachment. I'll share you the link. Okay, then I'll share the link.
Okay.
If I share now my screen again, limitations, we were here. Now can you see the screen here? These are the types of, like, how your tendons can be placed in your pre-stressed concrete. This is concentric. I take my pencil. This is your concentric. That means your tendons are placed here at the center. See, at the center it is placed, so it is known as your concentric tendons. Okay, this is your section. Okay, so here, after giving the tension to the tendons, then when you release them and generate the pre-stressing forces, these are your pre-stressing force, these two you can see from both sides. So whenever your tendon is at the center, placed at the center, it is known as your concentric tendons. Next, if you see concentric tendons, and one is your eccentric tendons. These are your eccentric tendons with an eccentricity. They are not right at the center. They can be like this. You see here, there is tension here. There is eccentricity here. This one. This is your, you see here, this is your eccentricity. Here, this that means this. I'm talking about this. Okay. This thing now, here it is in tension. This member you can see hold down force. You can see here this is the supports. Tendon anchorage is done here. From the jack they are pulling the tendons, and then anchorage is also done here. Sometimes your tendon may be, in this case what happens, due to this tension, when they have given the tension and then they have left the this thing, the your tendon, from the tension they have released from the, when they has released the tendons, what happens, your tendon may bend in this way. Okay, this is your eccentricity. So eccentric tendons, or sometimes what may happen, this is your tendon, sorry, this is your beam here, this this is your, draw a square. Suppose this is your beam. Now if I take this line here, and now if I take here, this is your suppose at the center you have your tendon, sorry, this is the center, but your tendon is placed somewhere, your tendon is placed somewhere here, this is your tendon. Okay, so in that this case you have an eccentricity here, this is your eccentricity. Okay, so these are known as your eccentric tendons. When your tendons are placed at the center, they are known as concentric tendons. When they are placed at an eccentricity from the center, it is known as your eccentric tendons. You will get some problems on these, like you will be asked to find out the pre-stressing forces, or the stress is developed at the top fiber and at the bottom fiber, how much is the stresses, okay, at the mid span or the end span, you will asked to be calculated, you will asked to calculate. So in that case you will have to know what is your eccentric tendons, what are your concentric tendons. Now, okay, I was simply drawing here, it is, the figure is already here. Which certain difficult. See here, you can see my screen, I think. Um, Here, this is your tendon placed here, this one, and there is an eccentricity here. This was the center of your beam, and here your tendon was placed at the bottom. Since we know the beams are under tension at the bottom, so the tendons are placed here, and this is your pre-stressing forces are here. Sorry for the noises. Construction is going here nearby. So these are your pre-stressing forces which are developed. You can see the section. If you see this section here, this is your center and this is your tendon here at the eccentricity. This is your eccentricity. This is your eccentricity. Okay. So now when you have a pre-stressing stress here, what will happen? This is the direct stress which is developed. How many stresses will be developed here? See, when you have this eccentric load, then your this stress will be distributed evenly among in the entire section. So that is given by direct stress, which is the total stress divided by the cross section area. This stress will be developed, the stress, direct stress, will always be developed due to the pre-stressing force. Okay, and when there is an eccentricity, what happens? Your bending stress will be developed. Okay, so that is P into E, that means this pre-stressing force into your eccentricity, that means the moment, okay, divided by your section modulus, that will give you your bending stress. Whenever you have an eccentricity, you will have a bending stress, but if you don't have an eccentricity, you have a simple concentric this thing, tendon here, concentric tendons are at the center, then only direct stresses will come. And here Since eccentricity is there, so your bending stress has come. So your total stress, resultant stress will be how much? Your direct stress plus your this thing bending stress, and so therefore your resultant stress will be this. So obviously you can draw the stress diagram once you know the values. Okay, I think my meeting will end here. I think I'll take the attendance. Okay, otherwise I'll have to, some of you will be missed like yesterday. I'll take the attendance. Okay, now in meeting may get over. Okay,
Okay, ma'am.
the section A. Section A, this is 21. Okay, roll number 1, Stephanie. Stephanie. Roll number 2, 4,
Ma'am.
5, 4.
Yes, ma'am.
Okay,
Ma'am,
when
for
I call
present.
your when I call your roll enrollments, like if I'm saying 4, whoever is 4, you say 4. Okay, so
4.
that I can okay. 5, 5.
5. Yes, ma'am. 05.
Okay, 6, 6, 7,
Yes, ma'am. 7.
8, 9, 10,
10.
11,
11 present, ma'am. 11.
12,
Yes, ma'am. 12 present.
14,
14 present, ma'am. 14
15,
present.
Yes,
15,
ma'am. 15.
16, oh sorry, 17,
17, ma'am.
18,
18, ma'am. Yes, ma'am.
19, 20,
20, ma'am.
19, Moakum Imchem, Sana. Now 20,
Yes, ma'am. 20.
21, 23,
Present, ma'am.
24,
24, ma'am.
25, 26, 27, 30, 31, 32,
32, ma'am.
34, 35, 36, 37,
37 present, ma'am.
38, 39,
Yes, ma'am. 39.
42, 43,
Ma'am.
45,
Present, ma'am. 45.
46, 47, 48,
48 present, ma'am.
49. Edit the Burma.
49, ma'am. Present, ma'am. 49.
50,
50, ma'am.
51,
51 present.
52, 53, 54,
54.
55, 56, 57,
Yes, ma'am. 57.
58, 58, 59, 60,
60, ma'am.
61,
60.
61, ma'am.
61, 63,
Yes, ma'am.
61, ma'am.
63.
61 I gave, 99, 99, 101,
Yes,
104,
ma'am. 101.
104,
Present, ma'am. 104.
104, 9 Acho,
Present, ma'am. Yes, ma'am.
104,
Present, ma'am. Present, ma'am.
okay, 106,
Ma'am.
107, sorry, 108,
Present, ma'am.
8 na?
Yes, ma'am.
9, 109,
Yes, ma'am. 109.
okay,
109.
okay. Triple 1, 111, 113, 1,
113, ma'am.
okay, 114,
Present, ma'am. 114.
118,
8, ma'am.
118,
Present, ma'am.
120,
123.
124,
Yes, ma'am.
133,
33 present.
134,
Ma'am.
136,
Oh, it's present.
143, 144, 145,
145 present.
148, 149,
149, ma'am.
149, G Momin.
145.
Yeah, 45 I gave. 148,
149, ma'am.
okay, 150,
Yes, ma'am.
Katang 151, Chiranjeev Dika, absent. Somebody has commented 63.
Yes, ma'am.
63 is given. 49 is given already. 26 is not given. Mangam also. So I'll share with you the link, okay, where you can